This is our second homework problem from Friday, chapter 4.8, page 170, problem number 6. It says at 7 a.m., Joe starts jogging at 6 miles an hour. At 7:10 a.m., Ken starts off after him. How fast must Ken run in order to overtake him at 7:30 a.m.? All right, remember I said a chart's optional, and they didn't already have a chart set up for you. But I said a picture is a must. If you don't do the picture, you're not going to get the problem right, most likely. So in class, we said there's a couple options for pictures. You can have two people going the same direction, starting from the same place. You can have two people starting from different places, going towards each other, same direction. You might have different legs, first leg of a distance or second leg of a distance. What else did we say? Opposite directions where they meet in the middle. And each one of those scenarios gives you different equations you can use. Now for the scenario we have here, they're both starting at the same place and headed in the same direction. So this is the kind of picture you're going to use. So let's let this first arrow represent Joe. Okay, Joe starts jogging at 6 miles per hour. So we'll just label his arrow 6 miles per hour. It says he starts off at 7 a.m. So over here at the start, I'm going to just say 7 a.m. Okay, at 7 a.m. Joe starts jogging at 6 miles an hour. Okay, so we're pretty much done with that whole first sentence. Okay. And it says at 7:10 a.m., Ken starts off after him. So here's the second arrow is going to represent Ken, and he starts at 7:10. How fast must Ken run in order to overtake him at 7:30 a.m.? So over here at the end, 7:30 a.m. Now between 7:10 a.m. and 7:30 a.m., we have 20 minutes. Okay, so we know this is 20 minutes. Now it says how fast must Ken run in order to overtake Joe at 7:30. That means right here, it's 7:30 for both guys. They've both been running, or they both ran until 7:30 when they were at the same place. So if Joe started at 7, and then at 7:30 Ken catches up with him, Joe's been running for 30 minutes. Okay, so we know both guys' times. Joe ran for 30 minutes, Ken ran for 20 minutes. But we only know one of them's rate. Joe went 6 miles per hour. We're trying to find Ken's rate. How fast must Ken run in order to overtake him at 7:30 a.m.? So Ken's rate is our question mark. So I'm going to use R for rate. Miles per hour. Notice that your units are different. This is miles per hour, and over here we know our time in minutes. Now for this section, they gave me the formula rate times time equals distance. But you need to be mindful of your units. If you keep track of your units, you'll be sure to get the right answer. Now, we also know, in addition to meeting up at 7:30, we know that they've covered the same amount of ground. In other words, their distances are the same. So we want to find out what is Joe's distance what is Ken's distance? Because we know Joe's distance must equal Ken's distance. They've covered the same amount of ground. That's going to be our equation setup, our big picture. You're going to find both of them's distance and then set them equal to each other. Well, rate times time should give us Joe's distance. So we've got 6 miles per hour. We're finding Joe's rate, 6 miles an hour, times Joe's time. Joe's time is 30 minutes. Now we are wanting to come out with Joe's distance. And for distance, we're going to end up with miles. The only problem is my hours and my minutes don't cancel. This is the only unit I want left, miles. I need to get rid of hours and I need to get rid of minutes. Remember in class we said the only thing you can multiply by without changing something is 1, but 1 is a master of disguise. Any fraction where the numerator and the denominator are of equal value is a fancy, ugly form of 1. So in this case, we need minutes on the bottom of this fancy 1 to cancel, and we need hours on the top so that they'll cancel. So if I want what's on top to equal what's on bottom, we can put 1 hour and 60 minutes. So this is nothing more than an ugly, fancy 1. We call those conversion factors. We're going to convert minutes and hours to different units. So now my minutes will cancel, my hours will cancel, and the only unit that didn't cancel is miles, which is the unit I want. So now I can see what's left. We've got 6 times 30 times 6. Well, this is 6 times 10, if I want to get rid of the 60. I have a 6 in the top, I have a 6 in the bottom, so I can cancel. 30 is 3 times 10. I have a 10 in the top, I have a 10 in the bottom. Now the only number left is a 3 in the numerator. I have no more numbers in the denominator. The only unit left is miles. It's in the numerator. That's good. So the only thing left after I multiply is 3 miles. And we were dealing with Joe. So Joe's distance was 3 miles. Now again, we said Joe went the same distance as Ken. They both ran the same distance. They didn't do it in the same amount of time, but they ran the same distance. So if Joe ran 3 miles, Ken must have ran 3 miles as well. And again, we have rate times time equals distance. Now we're dealing with Ken. We don't know his rate. That's our unknown. We do know his distance, 3 miles, and we do know his time, 20 minutes. So before we start, let's just rearrange this equation so we have our unknown by itself. If I was multiplying by time, you can divide by time. Time over time would cancel. And you'd be left with rate equals distance divided by time. So let's go ahead and start with that. Rate equals distance divided by time. Okay? Use your units to help you not make mistakes. Our rate's going to be in miles per hour. Well, we're using R. R miles per hour. Okay. Our distance is miles. In this case, 3 miles. And we're going to divide by our time. In this case, 20 minutes. The only problem is I want miles per hour. I don't want miles per minute. So I need to get rid of minutes. The only way to get rid of minutes in the denominator is if I had minutes in the numerator. And the only thing I can multiply by without changing the value of this problem is 1. So this fraction right here needs to be a fancy 1, or a conversion factor. Again, if you get good at conversion factors, you won't have any problem when it comes to chemistry. And we want hours to show up. Right now it's not showing up anywhere, and we want it to show up in the denominator. So in our fancy 1, let's put hours in the denominator. For it to be a fancy 1, the top part must equal the bottom part. Well, we know that 60 minutes is equal to 1 hour. So since the top value of 60 minutes equals the bottom value of 1 hour, this is a fancy 1. Doesn't look like a 1, but it is. So now your minutes cancel. And we really don't need to see a 1. The only units left would be miles per hour, which is what we want. Now let's start simplifying. 20 simplifies to 2 times 10. 6, it factors to 10 and 6. If I have a 10 in the numerator and a 10 in the denominator, that's a fancy 1. I don't need to see it. I can even go further. 6 factors down to 2 and 3. A 2 in the numerator and a 2 in the denominator, those would cancel. So you have a 3 here in the numerator, you have a 3 here in the numerator, nothing in the denominator except hours, and your unit in the numerator is miles. So we've got 3 times 3 miles over hours. Your 3 times 3 is 9. So R is 9. 9 miles an hour. That's how fast Ken has to go to catch up with Joe. And that is the solution to the problem.